Okay, peptide is an unbranched. So, unbranched chain of amino acids. So, ibig sabihin, this is straight chain of amino acid. If there are two amino acids, it's called dipeptide. If there are three amino acid in a straight chain, they are called tripeptide. And of course, if there are a little more than that, polypeptide. If there are very numerous, then therefore that is polypeptide. Okay, so amino acid will be connected to another amino acid with a peptide bond. Okay, so if in a dipeptide, which is composed of two amino acids, so there's only one peptide bond. Okay, there's only one peptide bond in a dipeptide. In a tripeptide, of course, if there are three of, then therefore there's only two peptide bond, and so on. Okay, so the number of amino acids minus 1 para malaman natin yung number ng peptide. So if there are two amino acids minus 1, so there's only one peptide bond. If there are 4 amino acids minus 1, then therefore there are 3 peptide bonds. So peptide bond is a covalent bond between the carboxyl group of one amino acid and the amino group of another amino acid. Okay, so the interaction happens with the carboxyl of amino acid 1 and the amino group of the amino acid 2. So ang mechanism is this green, the oxygen coming from the carboxyl and the two hydrogen atoms coming from the amino group will interact together to form the side product water, and the remaining will be connected to each other. So the carbonyl group from the carboxyl and the nitrogen will be connected such that we're going to have an amide bond. Okay, so always bear in mind the peptide bond is actually the amide bond. Okay, so here we have the zwitter ion of amino acid 1. So this is the first amino acid. And this is the zwitter ion of the second amino acid. So sabi natin kanina, the interaction of the carboxyl group of the first amino acid and the amino group of the second amino acid happens so that the amide bond will be produced. So itong oxygen niya at saka yung dalawang hydrogen, may side product tayong water. Okay, and the carbonyl part of the carboxyl group here and the nitrogen or the amino group will be connected such that the peptide is the amide bond. Of course, ang hindi involved sa interaction natin dito ay yung alin ang hindi naki-interact, yung amino or NH3 positive of the first amino acid and of course the carboxyl group of the second amino acid. That's why, kung titignan natin doon sa structure nitong dipeptide na ito, it starts with the amino group of the first amino acid and ends with the carboxyl group of the last amino acid. And that's why, ang tawag natin dito sa first and last na to is the terminal. Okay? That's the terminal. And on the left side is the N-terminal or the nitrogen terminal, which represents the amino. And it ends with, on the right side most, or the end is the C-terminal or the carboxyl group. Okay, so again, ulitin natin, recap. It starts with the N-terminal and ends with the C-terminal. So, by convention, N-terminal is always on the left and C-terminal is located always on the right. Para pag binasa natin, okay, so from left to right. So this one, so this is the N-terminal and this is the C-terminal. The carbon atom, these are the, sige, kuha tayo ng isang. This is the amide linkage. And this is the amide linkage or also known as amide bond or the peptide bond. Okay, so makikita natin that this is the alpha carbon atom. The alpha carbon atom, we all know that it bears the residue. So R1 is H for glycine, CH3 is the R2 for alanine, and CH2OH is the R3 or the side chain of the amino acid serine. Okay, so kung makikita natin, meron tayong pattern. So we have here the N-terminal plus the alpha carbon atom, then the peptide bond, the second the alpha carbon atom of the second amino acid, then followed by the peptide bond, then the alpha carbon atom of the third amino acid, and lastly the C-terminal. Okay, so ang tawag daw natin dyan is the backbone of a peptide. Fix yan. Okay, this is the repeating sequence of the peptide bond and the alpha carbon atom, or that is the CH. Yung alpha carbon natin, ito yung CH natin. Okay, always bear in mind that the alpha carbon atom is actually the second carbon atom for every amino acid. Okay, and that alpha carbon atom is actually the one that holds the residue R or the amino acid side chain. Okay, so ang ating backbone daw ay repeating unit ng alpha carbon atom peptide bond. Alpha carbon atom peptide bond. So dito ito yung kanina sinasabi natin. So this is the alpha carbon atom, ito yung alpha carbon atom, and then we have the peptide bond. This is the second alpha carbon atom, the alpha carbon atom for the second amino acid rather, and then followed by the peptide bond. Ayan. So, repeating units lang yan. So, syempre, bago yung alpha carbon atom, of course, we have the N-terminal. And the last would be the C-terminal. Okay, so C. Ito yan. Okay. So, ang nag-iiba lang is ang nag-iiba lang actually dito sa ating structure is the identity of the side chain or the R in the that depends on the identity of the amino acid, of course. So, just like this one, dun sa unang example natin. We still have the N-terminal, the C-terminal, the backbone, and for every uh, for every alpha carbon atom, of course, we have the identity of the R group. Okay? So how do we name these peptides? So we have peptide nomenclature. Small peptides are named as derivative of the C-terminal amino acid. So ibig sabihin, parang ito yung magiging parent chain daw, yung pinakamalapit dun sa C-terminal. Why? Kasi nga, rule number 1, yung the amino acid that is located on the C-terminal, the nearest to the C-terminal, will always keep its full name. So, ganun daw natin papangalanan. So, kunyari, ang ating amino acid ay cysteine, serine, and methionine. Okay? So, ang sa pangalan daw, since alam natin that from left to right ang basa, di ba? From the nitrogen to the carbonyl, or from the amino to the carboxyl terminal, or N-terminal to C-terminal. Okay? So, rule number 1, kung ano daw yung pinakamalapit dito, yung pinakadulo, will keep the full name. So, therefore, this one will have methionine. That's why, yun yung explanation kung bakit sinabi nila na small peptides are derivative of the amino acid that are near to the C-terminal. Second rule, all other amino acid residues will have their name end with YL. So, kung kanina sabi natin sa rule number 1, yung pinakalas ay hindi papalitan, at eto naman daw yung mga nauna daw ay mag-change sa YL. Except, of course, we have 4 exemptions. Okay? So, let's review. The YL suffixes will replace the INE or the IC acid ending. So, sir, for example, alanine. Okay? Alanine ends with INE. So, papalitan daw yung alanine na yan, gagawing YL. So, therefore, magiging alanyl. Or let's have glycine. Okay? Glycine ends with INE, that's the name of the amino acid, of course, according to rule number 2, we drop the INE. So remove the INE and change it to YL. So therefore, that would be glycyl. Of course, we have 4 exemption. Before the 4 exemption, let's have also the IC acid. So if we're going to have glutamic acid, ang sabi sa rule number 2, you drop the IC acid, remove the IC acid, and replace it with YL. So therefore, glutamic acid will be named as glutamyl. There's a 4 exemption here. Una si tryptophan. Okay, so since it ends with AN, so remove the AN and change it with YL. So tryptophan will be named as tryptophil. Okay, cysteine, though it ends with INE, yung E lang ang idadrop natin dito so that it will become cystenyl. Okay? Then glutamine, hindi kasi natin siya pwedeng i-drop ng INE kasi magiging parehas sila ni glutamic acid kung magkataon. Okay? So ang exception si glutamine, ang idadrop lang natin ay yung E, katulad ni cysteine, such that glutamine would be named as glutaminyl, just to make distinction between glutamic acid. Okay? Kasi si glutamic acid, si glutamyl, and then si glutamine ang magiging glutaminyl. Okay? Asparagine, only drop the E and add YL pa rin, such that it will become asparaginyl. So asparagine, magiging asparaginyl. And the rest of in the list of the 20 standard amino acid will follow the replacement of INE and IC acid with the YL. Siyempre, except itong 4 na to. Kung saan yung AN suffix at yung last na E ang pinalitan. Okay? Nevertheless, all of them will be having the ending YL. Okay? If and only if, of course, nandun sila sa unahan at hindi sila nasa last. Kasi we have to follow pa rin rule number 1 na sinasabi na yung pinakalas ay magre-remain ng full name. So, rule number 2, kung ang amino acid ay hindi siya yung pinakalas, i-change natin yung kanyang nomenclature, yung name niya with the ending YL. Okay? So, rule number 3, the amino acid naming sequence begins with the N-terminal amino acid residue. Kasi nga, from left to right yung basa natin. So, say for example, we have here glutamic acid, and then we have serine and alanine. Okay, so paano natin to papangalanan? Of course, sabi natin kanina, rule number 1, the alanine will retain its name. So, retain si alanine. Si glutamic acid, we drop the IC acid and we add the YL. Hindi siya kasama dun sa exemption, so it will become glutamyl. Serine will drop the INE and become cereal. So therefore, the name of this glutamic glutamic acid, serine, and alanine tripeptide will be glutamyl cereal alanine. Okay? Wala na tong sins. Okay? So this one will be named as, ulitin natin, the name of this tripeptide is glutamyl cereal alanine. The last amino acid retains its name, hindi napalitan yung pangalan niya. Yung mga naunang amino acid na change sa YL yung ending nila. Okay? And of course, this one would be as one word. So, walang spaces dyan. Okay? Another example, ito naman ay tetrapeptide. 4 yung kanyang amino acid. So, glycine will become glycyl. We drop the INE and add YL. Tyrosine become tyrosyl because we drop the INE and add YL. Leucine will become lucyl by dropping the INE and replacing it with YL. And valine, since it is the last, remains valine. So, unchanged sa. So, ang IUPAC name ng tetrapeptide na ito ay glycyl, tyrosyl, lucyl, valine. So that is the name of the peptide given. Okay? Now, what about for isomeric peptides? Okay? Isomeric peptides are the peptides that contain the same amino acid but different order. So therefore, with that difference in order, they are considered different molecules since they are isomers, and of course, they are different properties. So say for example, meron tayong peptide na ang composition niya ay alanine and glycine. Okay, so since pwedeng daw ang composition niya ay mauna si alanine and then followed by glycine, or mauna si glycine and alanine. So, nakita nyo dito, same yung content nila, pero yung different yung arrangement or yung order. And with that, ito ay alanine glycine and ito ay glycyl alanine. So, magkaiba ang kanilang properties. Magkaiba silang molecule. They are both isomers of these two amino acid. Okay? So, paano natin malalaman kung ilan ang isomers? Okay? So, meron tayong rule. Meron tayong formula rather. If we have here two amino acids, ang kanyang isomers lang ay dalawa. Okay? Kapag may tatlo tayong amino acid, okay, sabi nila kapag may tatlo daw tayong amino acid, ang possible count ng kanyang isomer ay 6. Okay? Because of the using the permutation 3 factorial, so that would be 3 times 2 times 1, so that would be 6 isomers. Okay? So, paano yung arrangement? Of course, ito yon. So, you have here A, S, C. Pwede rin daw na A, C, S. Ayan yung pangalawa. Yung pangatlo, C, A, S. Ito naman yung C, S, A. Yan yung pang-apat. Then yung pang-5, S, A, C, and S, C, A. So, wala nang ibang combination. At dahil dito, yan, na-satisfy natin kung paano yung computation nung pag-count kung ilan ang possible isomers. Of course, kung meron tayong 5, hindi na natin iisa-isahin. Hindi na natin iisa-isahin ng aayos natin isa-isa. Okay? Rather, gamitin na lang natin yung formula. If we're going to have 5 different amino acids, so 5 factorial, so that would be 5 times 4 times 3, so pababa lang, times 2 times 1, so that is 100. Sorry. Okay, times 1, so that is 120. Okay, so ganun mag-compute kung ilan yung isomers na pwede. So ulitin natin, isomers have the same identity amino acid. It contains the same amino acids but different in order. They're considered different molecules and they possess different properties. Okay?